Let's take a look at another example. Here, we just have two numbers. 8 is greater than 4. And we all know that 8 is greater than 4. Or we could read it even backwards. 4 is less than 8 because the inequality points towards the 4. Well, there's a rule that says that when we multiply by a negative, we have to switch the inequality sign. So let's just see why that's the case. So if I rewrite these numbers down, 8 and then greater than 4, if I end up multiplying both sides by, let's say, negative 2. So let's say I put a times sign here and I put negative 2 on this side, times sign here and negative 2 on this side. We said whenever we multiply or divide by a negative, again, that sign switches. So if we go ahead and multiply these two numbers, we end up getting negative 16 on this side. And here, when we multiply these two, we get a bigger number. We get negative 8. See, when you multiply by a negative, by a bigger number to start with, it becomes a lot smaller because the sign switches to a negative. 2 times 8 is 16, but it's a negative 16 because we have one negative. Here we multiply the negative 2 by a smaller number, so it'll be negative, and 4 times 2 is 8, but it is bigger than negative 16. So we had to switch the inequality sign around. So whenever we multiply or divide by a negative, it's going to switch the signs. And so it'll switch not only the signs of the number, but then also the inequality, because the number that was bigger to start with will now be smaller because it's a negative. So we are going to have to remember that rule when we solve inequalities and divide by negatives. So let's take a look at a problem. Let's say we had negative 3y plus 8 is greater than or equal to 29. So our first step is to isolate the variable. So we're going to go ahead and do the opposite of a plus 8, which is minus 8. So we'll take away 8 from all sides there. And when I do that, I still have this 3y, or negative 3y. And it is greater than or equal to, and then when I do that subtraction, I end up with 21. Now, we need to do some division to undo this multiplication of negative 3. So we're going to divide by a negative. And so we have that same rule as we did here. When we divide or multiply by a negative, the bigger number is going to end up becoming smaller because it switches to a negative. So here, this number, which is now bigger than 21, is now going to end up being smaller because we're going to end up having to divide by the negative, which cancels out the negatives here. And we're going to end up just with this value of y is now less than or equal to, and then we do the division here, we end up with negative 7. So if I was to graph this, I'll start with the end point, negative 7 in the center, and then I'll have the bigger number, negative 6 to the right, and the smaller number, negative 8 to the left. And I'll have to use the appropriate type of circle. So it's less than or equal to, so I have to use a filled-in circle on that negative 7, and then draw the line to the possible values of y to the left because it's less than. So to make this statement true, I would need to have values of y that are negative 7 or smaller, like negative 8. See, if we go ahead and just mentally plug this in, negative 3 times by negative 8. So we'll do that work off to the side here. Negative 3 times by negative 8 makes 24, makes a positive 24. And when I add 8 to that, I get something that is greater than or equal to 29. See, when I add these numbers together, I get 32. and that is greater than or equal to 29. So because we are dividing or multiplying by a negative, it will end up switching the inequality sign, because then the bigger number becomes smaller. The smaller number becomes bigger when we divide or multiply by a negative. So the next example we'll see is one where we have the expression that has the variable term on the opposite side of the inequality.